Having understood various properties which make certain situation a game, and representation of the game, reading the game, finding minimax, maximin, and if minimax is equal to maximin, then the game has saddle point, and if the game has saddle point, each player in the game is supposed to use pure strategy, means only one course of action available to amongst various courses of action available to him. Now, in this lecture, we'll be seeing various methods of solving the game. The very first being algebraic method. We'll be taking a very small problem. In fact, algebraic method is applicable to the game in which both the players has only two courses of action available to him. And say this is the game given to you. Player A has two courses of action available to A1 and A2, and player B has two courses of action available, B1 and B2. And this is the payoff matrix. Very first, before we apply any method, we will be finding out whether the game has saddle point or not. So what we will be doing, we will be finding minimum guaranteed gain for player A. If he plays A1, for that we will be finding minimum value in this first row, and that comes out to be 1. And for if the player plays A2, what is the minimum guaranteed gain? That is the minimum value in the second row corresponding to course of action A2, and that is minus 5. So maximum amongst the minimum guaranteed gain is 1, and that happens to be maximin. And same thing we'll be doing for player B. We'll be finding maximum possible loss for player B if he plays B1 and B2. For that, we need to find out maximum in the B1 column, that happens to be 7, and maximum in B2 column, that happens to be 3. So amongst this maximum possible loss, what we'll be doing, we'll be finding a minimum. Okay, that minimum happens to be 3. Okay, now here we are seeing that maximin is not equal to minimax, and if that is not equal to maximin is not equal to minimax, game doesn't have saddle point, no saddle point. But one thing is very clear here, that the game value will be lying between 1 and 3. This is the lower bound of the game value, and this is the upper bound. You will always see in any game that the minimax is always greater than or equal to maximin. If minimax and maximin are equal, then the game has saddle point. If they are not, then minimax will always be greater than will always be greater than or equal to maximin. So that gives us the range within which the game value lies. Game value lies between 1 and 3. Now, it is very clear that player will not be playing only one course of action. He will have to use more than one course of action. Right? Now the question arises, in which proportion each course of action will be played. So for that, as the proportion is not known, we'll be taking that as variable. For example, here we assume that A1 will be played in X proportion, and obviously A2 will be played in 1 minus X proportion, because sum of the proportion is 1. So if A1 is played in proportion X, A2 will be played in proportion 1 minus X. Simultaneously, we will also be assuming that player B will be playing B1 in Y proportion. By Y is the proportion in which B1 will be played, and obviously 1 minus Y will be the proportion in which B2 will be played. Our target is to find value of X and value of Y. Once we find value of X and value of Y, we will be getting the proportion in which A1, A2 and B1, B2 will be played. So for that, the logic is the expected gain to player A will be same irrespective of the course of action selected by player B. Expected gain to player A will if player B plays B1 will be exactly equal to expected gain to player A if player B plays B2. So choice of player B mm, will not make any effect on the expected gain of player A. So what we'll be doing, we'll be finding expected gain of player A if player B plays B1. What will be that? 1 into x plus 7 into 1 minus x. This into this plus this into proportion 1 minus x. So 1x plus 7 into 1 minus x should be equal to 3 into x minus 5 into 1 minus x. That's it here. Now that we have got this equation, this simplifies to minus 14x is equal to minus 12 and giving you the value of x equal to 12 by 14. Once x is equal to 12 by 14, that gives you the proportion in which a1 should be played and a2 will be played obviously in proportion 1 minus 12 by 14 means 2 by 14. The sum of the proportion has to come 1. And now we'll be trying to find the proportion in which B1 will be played and B2 will be played. So for that, what you will have to do? Expected loss to player B should be if player A plays A1 should be same as expected loss to player B if player A plays A2. So expected loss to player B comes out to be equal to 1 into y plus 3 into 1 minus y. 1 into y plus 3 into 1 minus y is equal to 7 into y minus 5 into 1 minus y. So here that equation is okay. And now once you have that equation, only one variable is there that can be easily solved to get you the value of y. So this equation simplifies to minus 14y is equal to minus 8 and therefore y is equal to 8 by 14. So that gives you the proportion. Y means the proportion in which B1 is played, that is 8 by 14. Obviously B2 will be played in proportion 6 by 14. 1 minus 8 by 14 is 6 by 14. So that is how the game is solved by the algebraic method. Solving the game means finding the proportion in which course of action A1 and A2 for player A and proportion of course of action B1 and B2 for player B will be played, right? And now what is the game value? Game value will be the proportions multiplied by the P of if player B plays B1, right? For example, 12 by 14 multiplied by 1 plus 2 by 14 multiplied by 7. So that comes out to be equal to 26 by 14. So game value is 26 by 14. If you multiply this proportion, that is 12 by 14 and 2 by 14 with this column and add, you again will be getting 26 by 14. If you take the proportions which you have obtained 8 by 14 and 6 by 14 and multiply, you take the sum of the product of these proportions and this row, that will be, that is how much 8 into 1, 8 by 14 plus 18 by 14. Why 18 by 14? 3 into 6 by 14, 18 by 14. That also comes equal to 26 by 14. Also 8 by 14 into 7, right? That is 56 by 14 minus minus 5 into 6 by 14, that is 30 by 14. 56 minus 30, that is 26 by 14. So if these are the proportion, only in that case the sum of the product of the proportion and the payoffs, if player B plays payoffs, if player B plays B1 will or B2 will be same, and that is 26 by 14. Any other proportion taken here won't give you this kind of result. So you can take the solving of the game in a spirit of puzzle. It is simply finding the proportions, finding these values. finding the proportions in which all the courses of action will be played such that sum of the product of the proportion and payoff for any column will give you same value, which is called as game value, right? Now, from this algebraic method, something which I skipped to write in this algebraic method, I have written in the next method, arithmetic method. Anyway, algebraic method won't be used so often because there is another method which is derived or which is extracted from algebraic method itself. So in the presence of algebraic arithmetic method, algebraic method will not be used, but the background of this arithmetic method is algebraic method itself. What is done in arithmetic method? I have taken the same problem, right? So what I'll be doing, I'll be taking the difference between these two, 1 and 7. First row element 1 and second row element 7 in column B1. I'll be taking the difference and I'll be writing it in odd place. That is called as oddment. 1 minus 7 is minus 6, but I have to write modulus absolute value of that, that is 6. Okay, 3 minus minus 5, that difference I'll be writing here, right? That comes out to be equal to 8, right? And a similar way for this, I'll be doing 7 minus minus 5, the difference come equal to 12, and 1 minus 3, that difference come equal to minus 2, but you have to take absolute value, so the difference is 2. Now what you have to do after this, you make the sum of this 8 plus 6 14, that you take as the denominator to both these values. So 8 by 14 and 6 by 14 are the proportions of course of action B1 and B2, and here on the A side, you take the sum of this two, 12 plus 2 14, and put that sum in the denominator of 12 and 2, so you get here the proportions 12 by 14 and 2 by 14. These are the proportions of course of action A1 and A2. See how simply this game has solved. Solved means it has given you the proportions of course of action A1 and A2 and B1 and B2. Proportions are obtained for both the players. That is, but this proportions we have obtained, this method is extracted from algebraic method, right? Now, mm, just look at this. Strategy for player A. Strategy for player A is going to be for player A 12 by 14, 2 by 14. A1 will be played in proportion. Out of 14 times, 12 times A1 will be played and A2 will be played 2 times. Right? So 12 by 14 and 2 by 14 is the strategy for a player A, and for player B 8 by 14 and 6 by 14. Strategy means the proportion in which each course of action will be used by players A and B. It is the statement of proportion in which each course of action will be used by corresponding player. Now lastly, game value. What is game value now? Game value is nothing but the proportions multiplied by the value in any of the column. You may take any of the column. All the columns, all the sum of the products are going to give you same sum of the product. Okay. For example, 12 by 14 into 3, that is 36 by 14 minus 10 by 14, 26 by 14. That comes out to be 13 by 7. If you take this into this, 12 by 14 plus 14 by 14, that is 26 by 14. Again, if I take this proportion into these values, 8 by 14 means 56 by 14 minus 30 by 14, that is again 26 by 14, and lastly this values multiplied by this again is going to give you what 8 by 14 plus 18 by 14, 26 by 14. So you may not do all this. That is just I have explained to you that by all the ways sum of the product comes equal, and that's what is solving the game. It is simply finding this proportion such that if you make the sum of the product of these proportions and this proportions and this proportions and this value, this proportion and this value, everything will give you same value, which is called as game value. Okay, right? In this proportion, the courses of action will be used, right? In if they are used only, if they are used, if the proportions are used in this proportion, then only it will be called as game is played. All right, game is played, right? So game value, once again I'll reiterate it that game value is average winning or losing, winning for player A and losing for player B over long number of plays. So that is how we'll be solving the game. But this method is applicable. Arithmetic and algebraic method is a very primitive method and applicable to 2 by 2 game. If your game is 2 by 2, okay, or if it should finally get reduced to 2 by 2 by principle of dominance, right? By principle of dominance. So, if the game gets reduced to size 2 by 2, initially it may be bigger size, but if finally it gets reduced to 2 by 2 size. In last lecture, you have seen the principle reducing the matrix, payoff matrix by principle of dominance, but that time, if you recall, it was a 5 by 6 game, 5 rows and 6 column, that finally got reduced to 3 by 3. So this algebraic method or arithmetic method cannot help you to get the strategies for player A and strategies for player B. There will be some other method in that case. So if the game gets reduced to 2 by 2, then only you can use arithmetic method, right? So now, if the game is not 2 by 2 sides, okay, 2 by 2 means two courses of action available to player A and two courses of action available to player B. Hmm. So if the game is not 2 by 2, then what? Suppose say, but the game is having something, either the rows or the column 2, right? For example, here there is a game. This is a game in which player A has two courses of action available to him, and player B has three courses of action available to him. Okay, so the arithmetic method will not be useful for solving this game. But there is one principle that the number of courses of action used by any player is decided by the player who has less number of courses of action available to him. It is simply, for example, there is a game going on, or some small kids have decided to play, and they form two teams. All right. So whichever team has less number of players will decide the number of players of any team playing the game. That's exactly the same principle here. Player B has three courses of action and player A has two courses of action available. So player B won't be able to use more than won't be able to use more than two courses of action. Player B also will have to use two courses of action, because who is deciding the number of courses of action used by any player? The player who has less number of courses of action available, and player A has less number of courses of action available too. So player B will be using two courses of action. Now the question arises, which two will be used by player B out of the three available to him? The answer is very simple. Those two courses of action will be used by player B, which will result in minimum loss to player B. Why minimum loss? Because whenever I think through the perspective of player B, I have to think in terms of loss, and loss is to be minimized. So player B will be choosing those two courses of action, playing which will result in minimum loss to player B. So what I'll be doing, I will be splitting the game. I'll be forming various combinations of the courses of action selected by player B. I have to select two out of three. So those could be B1, B2, or that could be B1, B3, or that could be B2, B3. So what I'll be doing now, I'll be solving all these three games. So this is called as, because why I'll be solving three games, because by doing this I can convert the game to many 2 by 2 games for which I know the method, right? So this is called as method of sub game. So what is done? First of all, I'll be breaking this game in which player A will be having courses of action A1, A2. Player B will be choosing to play B1, B2, right? B1, B2. And in the second sub game, which I'll be attempting, in that player B, I am trying. Player B will be choosing to play B1 and B3. Player A still will be playing A1, A2. All right. Player A will be playing A1, A2. And third time, I'll be playing the game. I'll be taking the sub game in which player B plays the courses of action B2 and B3. A has no choice because it has only two courses of action. So this I form three sub games, and all these sub games obviously will be 2 by 2, and for which I know the method. But there is one point of caution: before you use arithmetic method or algebraic method, you first have to check if the game has saddle point or not. If the game has saddle point and still if you use arithmetic method, then you will be doing wrong. First check. You have to use either of these two. If the game has saddle point, then you will be straightway getting the solution to the problem. You don't have to, or you should not, you must not use arithmetic method. All right. And if the game doesn't have saddle point, you should use arithmetic method if the game size is 2 by 2. So very first step which I'll be performing here is to check whether the game has saddle point. So what I'll be doing, I'll be finding minimum guaranteed gain for both these rows. MGG I have found minimum in this row is -50, minimum in the second row is 125. Okay. So maximum amongst this minimum guaranteed gain is 125, and for column B values are 275, 125, and maximum possible loss there is therefore is 275, and for column B2 maximum value is 130 as you see here. So minimum of maximum possible loss is 130. Now, maximin is not equal to minimax, therefore the game doesn't have saddle point, no saddle point. And once the game doesn't have saddle point, you are free to use arithmetic method. Rather, you have to use arithmetic method. And what you have to do, you take the difference between these two, write the absolute value of that here at odd place, right? The difference of this you have to write here. Different here you have to write here. All right. And then the another right here, you just look at here the difference 275 and 50. 275 and 50, the difference comes out to be 325. 275 minus 50, 325. So immediately you get both the oddments. We are calling them as oddments because they are written at odd place. Okay. Like normally this difference I will be writing just below it, but I am not doing that. I am writing it at odd place. All right. So the sum of these two differences is coming out to be 330, and that will now come in the denominator to finish that up. 5 by 330, 325 by 330 are the proportions of course of action A2. All right. Here, even though I have found out the proportions of courses of action for player B, I will advise you not to do these computations before you complete the other computations. Okay, so these computations I will be putting pending. I will put pending, even though I have done it, but I will advise you not to do these computations, okay? Because once I get the proportions, I will be finding the game value. Finding the game value for sub game is important. Once you get that, you can proceed to solving next sub game. So having got these proportions, 5 by 330, 325 by 330, multiply these proportions with any of the column here. So, so what I get, minus 5, minus 50 into 5 by 330 plus 130 into 325 by 330, I get game value 127.30. Okay, you don't do this calculations now, which are that way easy. Doing won't consume much of a time, but it will waste some of your time. So you may not do this computations right before you do every other thing. So I will now proceed to solve another subgame wherein I have B1 and B3 courses of action for player B. So I'll be getting this matrix. The values from here in the corresponding columns are entered here. B1 column values here, B3 column values here. Right. Once again, before I use arithmetic method, I will first check whether there is a need for using arithmetic method or not. All right. So for that, I will be finding, you have to find minimum guaranteed gain in each of the row. So minimum guaranteed gain for first row for A1 is minus 75, and for A2 is 125. Maximum of minimums is 125, rounded there. Now find the maximum possible loss. Maximum possible loss is coming out to be here 275 and here 150. Minimum of maximums is 150, and we are finding that maximin is not equal to minimax, so there is no saddle point. Now you should use arithmetic method. So what you will be doing now? You will be finding this difference and writing here 125 minus 150 minus 25, but you have to write absolute value there, that is 25. Then 275 minus 75, that is 350. Okay, and you make the sum of this and put that sum in the denominator of these two values. That will get you the proportions of course of action A1 and A2. Sum comes out to be equal to 375. So your proportion of course of action A1 is 20 by 375, and proportion of course of action A2 is 350 by 375. Okay, these proportions are enough for getting the game value. So and your target, your priority is to get the game value. So you again need not do these calculations right now. Okay, you may have to do these calculations, but later. So priority is finding game value. If you get that game value directly, so what you will be doing for getting the game value, this proportions multiplied by any of these two columns, whichever you find comfortable for doing the computations. So minus 25 minus 75 and divided by 375 plus 150 into 350 divided by 375, the game value comes out to be equal to 135. All right. Now you have the third game to solve. Now third game is because of courses of action B2, B3. All in all, what you have to do is first you try solving the sub game with courses of action B1, B2 for player B, then B1, B3 for player B, and then B2, B3. So that you must be convinced that you have tried all combinations. So B2, B3 column values you will be just copying here. So that comes out to be minus 50, 130, minus 75, 150. From there I have taken here. Right. Now once again I need to get convinced whether the game has saddle point or not. So I'll be finding minimum in each of the row. Here it comes minus 75, here 130. Out of these two, 130 is maximum. From minimum guaranteed gains you have to find maximum. Okay, and for maximum possible loss, MPL, maximum in each of the column you find. In first column is 130, in second column is 150. You have to find minimum amongst those, and that is 130. So what is happening here? Minimax is equal to maximin. That means game has saddle point, and once the game has saddle point, game value is obtained directly. That is 130. It is a value of minimax or maximin. Both are same. So game value is obtained. Now that you have solved all possible combinations for player B, you have tried various possible combinations of the courses of action, that is choosing 2 out of 3. You have solved all combinations, and player B will be choosing that course of those two courses of action, playing which will give or result in minimum loss to player B. Okay, minimum loss to player B means you will have to search the game with minimum game value. And which is the game with minimum game value? Minimum game value game. Here, this is 127.3. We have found that out. This is 135. All right. This is 135 and this is 130. Amongst all this is the game which you need to select. And once you select this, you complete the formality about that game. Okay, you have, if you had not found the proportions here, you need not find it. Okay, that time you definitely are going to save. But here you have to find it out. Okay, here initially we have not found this proportions, but now that this game is selected, so do all the formalities which we left to do now. Okay, so what we'll be doing, we'll be finding this difference minus 50 minus 130, 180 absolute value here, and 275 minus 125, 150. So you make the sum of this and put that in denominator, so that what that comes, 180 by 330, 150 by 330. That is how to solve the game. And what will be the answer? Answer is to be written like this. Strategy for player A. You already have it. 5 by 330, 325 by 330. What is the strategy for B? 180 by 330. Player B will be playing B1 in this proportion. Out of 330 times, B1 will be played 180 times, should be played 180 times. And B2 150 times out of 330. And B3 is never to be played, will not be played. And that's why 0. You don't forget to put means every value, because here we are not writing of which this is the proportion, so you have to maintain the sequence. Okay, first value, first proportion essentially is the proportion of course of action B1. Second essentially is the course of action B2. Third essentially proportion of course of action B3. So if you don't have proportion for some of the course of action, you should not forget to write 0 there. And finally, game value, you have already found that out, 127.30. So all in all, player B had the choices, and if you have the choice, you should be using choice in best possible way. Okay, and that is the approach for solving the uh, the 2 by m or n by 2 game by method of subgame, right? So we'll be seeing if player A has got choice of course of action, and player B has only two courses of action available. Okay, we'll get into that kind of game. Okay, I hope this is understood. In nutshell, you have split the game into three sub games, and that's why we call this method as method of sub game, right? So this sub game was b1 b2. The player B has courses of action b1 b2, this has b1 b3, and this has b2 b3, and we finally have selected that game which had given us minimum game value. Why? Because B was to make a choice, and B will be making the choice of those two courses of action, which results in minimum loss to player B. So minimum game value, that's why. Okay. Now another problem we'll be seeing by method of subgame, right? So this is the problem given to you. It's now 4 by 4. I want to tune you with various situations of the game. So this is 4 by 4 game. Okay. So very first, before you proceed to solve any game, you should look into whether the game has saddle point or not. Okay, then once you are convinced that the game doesn't have saddle point, then only you should do any other thing. Okay, so in this game, very first I'll be finding out minimum guaranteed gain and maximum possible loss. All right, so let's find that. So let us find MGG. All right, minimum guaranteed gain. The minimum for this row is 6. All right. No, not 6. It's 5. And then for this it is 3. For this row it is 4. And for this row it is -1. This process is to be done even before you reduce the game by dominance principle, because even that will not be needed if you get the saddle point. Your game will get solved there itself. So this being an easy process, you have to carry that out very first. And maximum possible loss, MPL, maximum possible loss, is from this column it is 19, 19, from this column it is 8, from this column it is 18, and from this column it is 6. So minimum amongst all this is 6. Okay, 19, 8, 18, 6, 6 is minimum. And as far as these values are concerned, maximum is 5. So minimax is not equal to maximin, but one thing is clear, your game value finally will be coming between 5 and 6. In last problem also, we didn't have the saddle point, right? And that time we forgot to do that process in the previous problem. Let's at least complete it now. Minimum guaranteed gain here is -75, and here it is 125. 125 is maximum, and maximum possible loss is 275 here, then 130 here, and then 150 here. Amongst all these values, 130 is minimum. Okay, so game doesn't have saddle point, but one thing is clear, that your game value will be lying between 125 to 130, and you are seeing that it lies between. It lies in between, not exactly midpoint, but it lies in between 125 to 130. That is the check. If this value falls outside that range, you are wrong. Okay, so that's upper bound and lower bound happens to be the guide for your answer. All right. So game doesn't have saddle point. This game doesn't have saddle point. But one thing is clear that game value will have to be between or will come between 5 and 6. Now let us try reducing the game by dominance principle because it has not got solved because the game doesn't have maximin equal to minimax. So we'll be comparing each row with another. Okay, so compare all these values, right? All these values 19 compared with 7, this is less, this is less, this is higher. So leave the comparison. Compare A1 with A3. This is less, 19, 12, 12 less, 6, 8, 8 more. Leave the comparison. Then compare A1 with A4. 19 and 8, 8 less, 6, 7, 7 more. Leave the comparison. Now compare A2 with A3. 7, 12. 12 is more. 3, 8. 8 is more. 14, 18. 18 is more. 6, 4. 4 is less. Alright. So means you cannot eliminate the course of action here. Now compare A2 with A4. 7, 8. 8 is more. 8 is more. 3, 7. 7 more. 14, 13. 13 less. Leave the comparison. Now compare A1 with A3 with A4. 12, 8. 8 is less. 8, 7. 7 less. 18, 13. 13 is less. And 4 minus 1. Minus 1 is less. So there is a consistent relationship throughout. So we, in the presence of A4, in the presence of A3, A4 will never be used. Why? Because A4 results in lesser gains to player A as compared to gains obtained by playing A3. So we will be eliminating A4 by writing a remark dominated by A3. Dominated by A3. Now we will be comparing columns B1 with B3. While you compare the columns, the column with higher values is to be eliminated because those higher values stand for the losses to player B. So higher losses should be eliminated, right? So 19, 6, 6 is lesser. 19, 6, 19 more, 7, 3, 7 more, 12, 8, 12 more, 8, 7, 8 more. So B1 column has higher values, so B1 column will not be used. B1 course of action will never be used in presence of B2. Now compare B2 with B3. All right. So 6, 7, 7 more, 3, 14, 14 more, 8, 18, 18 more, 7, 13, 13 more. All the values in B3 column are more, so B3 column will be eliminated. Okay. Now compare B2 with B4. 6, 5, 5, 6 more, 3, 6, 6 more. So you leave the comparison because one value in the column B4 is less and another is more. So you leave the comparison. So you finally are left with one more thing I forgot. I did a mistake here because in comparison, if the row gets cancelled, you should not do the comparison. Okay, I continued doing that, but if this A4 row was already out. Okay, so if the row is out, if the row is eliminated or the column is eliminated, you should not do the comparison pertaining to the eliminated column or eliminated row. Eliminated values won't be compared. Okay, so you finally are left with 653, 6, 8, 4. This is the game you are left with. Right? Player A has three courses of action available and player B has two courses of action. Which two? B2 and B4. Player A has A1, A2, A3. From this game, B1 and B4 has got eliminated. B1 and B3 has got eliminated. Now, player A will be using only two courses of action because we have already seen that the number of courses of action selected by any player is decided by the player who has less number of courses of action available. Right? So now player A has got the choice of which two courses of action are to be used, and he will be using those two courses of action, choosing which will result in maximum gain to player A. Why maximum gain now? Because when we talk of A, he is the player, he is you, and you are going to win, and you are going to win maximum. Okay, so A1, A2 will be taking all the possible combinations of A1, A2, A3, A1, A2. I'll be forming first game with A1, A2. That is, this is the first sub game I'll be dealing with. Second sub game with A1, A3. That is 6, 5 and 8, 4 values from corresponding row or column I am taking. Then a third subgame with courses of action A2, A3. So what are the values? 3, 6, 8, 4. Alright. Now solve the game one by one. But before you do any attempt, you first be convinced that the game doesn't have saddle point. Okay, if it has, it is solved there itself. You don't have to use arithmetic method. So you find MGG, minimum guaranteed gain. So out of 6, 5, 5 is minimum, and out of 3, 6, 3 is minimum. Among these values, 5 is maximum. Maximum is 5. Let's come in columns. So out of 6, 3, 6 is maximum, and 5, 6, 6 is maximum. So minimum among this is 6 itself. So game doesn't have saddle point because maximum is not equal to minimax. Right? So you have to solve the game ahead by arithmetic method. So what you will be doing, you will be taking this difference 3, 6, you will be writing it here, and 6, 5, you will be writing 6 minus 5, 1, you will be writing here. Here there must not be negative value because that this finally is turning to proportion. Alright. So sum of this comes equal to 4, and 4 happens to be the denominator for these values. So your proportion of A1 and A2 comes out to be 3 by 4 and 1 by 4. Okay, again here I did the process, but I should not do that before I get a game value for everything else. I may defer this. I may defer this computation for some time. Okay, let's proceed to solve second game. Once we have got game value, have we? This multiplied by this 3, 3 into 5 by 4, that is 15 by 4 plus 6 by 4, 21 by 4 is the game value for first game. Now for second game, 6, 5. Let's first point whether the game has saddle point or not. Right? So here come MGG, minimum guaranteed gain. 6, 5, 5 is minimum. 8, 4, 4 is minimum. Amongst this minimum, 5 is maximum. Okay, so that maximum we have obtained here. Let's find maximum possible loss, maximum values in each of the column. So MPL, maximum in first column is 8, maximum in second column is 5, and you have to find minimum of that, and that is 5 again. So maximum is equal to min-max, that game has saddle point and game value is 5. Okay. In this case, if you attempt to solve this problem by arithmetic method, you will be getting wrong result, wrong game value. So you first check whether the game has saddle point. If it has, don't use arithmetic method. If it doesn't have, use arithmetic method. Alright. So third sub game. Okay, values are 3, 6, 8, 4. Minimum is 3 for first row and 4 for second row. Okay, amongst this 3 and 4, 4 is maximum. Maximum is 4. And here, I forgot to write B1, B2, B1, B2. but you will be remembering that these values are b1, b2. Now in this column, 8 is what that? In this column, 8 is maximum and 6 is maximum. Okay. Mm, 8 is maximum. I don't have space for writing 8 maximum and 6 maximum. Just listen to those values. Those may not be very much legible to you. So this is 8. 8 is maximum and 6 is maximum. Amongst 8 and 6, 6 is minimum. What we are finding that the game doesn't have saddle point because maximin is not equal to minimax, no saddle point. So you have to go for what? You have to go for finding the oddments. Okay, 8 4 difference is 4 here, and 3 6 difference is 3 here. You make the sum of these two, you make the sum of these two, that comes 7. So 4 by 7 and 3 by 7 are the proportion. With this proportions you can find out game value. How? 6 4 is 24 by 7 plus 4 3 is 12 by 7. 24 plus 12, 36 by 7. This 5.5 plus 1 by 7. This is 5, and this is 5 plus 1 by 4. Okay, here you should not have hurried for finding the proportions of course of action b1 b2. Okay, so proportions of course of action b1 b2, you should not hurry for finding that. Because it may not be needed, that may not be needed to be found. Okay, right? So you compare the game values whichever is maximum, because player A will be choosing that course of action or those courses of action, choosing which will give him maximum gain, and maximum gain is here 21 by 4. By comparing all these game values, this is maximum. That means player A will be choosing to play A1 and A2 out of A1, A2, A3. Okay, now that this game is finalized, you do remaining formalities for this game. You now take this difference 5 6, you write it 1 here, 6 3 3 here. So sum comes 4. So 1 by 4, 3 by 4 are the proportions of courses of action B1 and B2 to be to be played. So after having done this, now you are in position to write the strategy statement for A and B. Strategy for A, okay. A will be played 3 out of 4 times, and A1 will be played 3 out of 4 times. This is a wrongly written strategy. I'll rewrite it. Strategy for A. Okay, I'll be correcting there itself. 3 by 4, 1 by 4, A2 will be played 1 by 4, but in original problem you have A3 and A4 also. You have to write about them also. 0 and 0. Right? 0 and 0, right? Because A3 and A4 will be played in proportion 0. They will not be played in fact. And the statement of strategy for player B, we already know that B1 is not getting played. We have eliminated it, so proportion is 0. Then B2, this in fact is not B1, B2, this is B2, B4. B2, B4. Proportion of course of action B2 is 1 by 4, B3 is eliminated, so 0, and B4 is 3 by 4, as you see from here. And game value you have already found that out, that is 21 by 4. Okay. Once again, if you simply write all these values here and here and do the sum of the products, you will get it for every row and every column. you will get 821 by 4, right? You don't have to do it, but just to make you understand the concept of solving the game, it is not more than finding the values, finding the proportions of course of action A1, A2, A3, A4, and B1, B2, B3, B4, such that proportion multiplied by the value in each of the row or in each of the column, what is relevant there, okay, should come equal. That's solving the game. Now this is called as method of subgame, but there is one problem in method of subgame. What the problem? Problem is here player A has only three courses of action available. Okay. What if A has five courses of action available and B has two courses of action available? One of the player has two courses of action available and another player has five. Then how many subgames you will have to solve? The number of subgames to be solved will be 5C2. Okay. If one player if one player has five courses of action available and other has two, all right, then number of subgames to be solved, number of subgames to be solved will be equal to 5, you because you have to select two courses of action out of 5. 5C2 means what factorial 5, that is 5 into 4 into factorial 3 divided by mm, factorial 2 into factorial 3, that is factorial 2 is 2, factorial 3 is factorial 3, let's write that. So it come number of subgames to be solved comes equal to 10. And for what? Many of them will not be useful. Only one subgame you will have to select after solving 10 subgames. That's not wise proposal. Okay, and if the number of courses of action available to one player goes on increasing, the number of sub games to be solved also goes on increasing. Just think of the case of 6, 7, 8, 9. This number will go on increasing, and that many sub games you will have to solve. Okay, and one sub game out of that many sub games you have solved, you will have to choose. This is unfair. Okay, not unfair, but not wise, right? So then, what is the way? There is a way. That way is solve the game by graphical method, and that graphical method, as a method of subgame is concerned, it is applicable if one of the player has two courses of action available. Okay, if one of the player has two courses of action available, so we now will be seeing graphical method to solve method of to solve the games, right? Not now, we'll be seeing those methods in next lecture. Thank you.